All right, so a big question I've gotten is what is a Triac and how does it work and how does it apply to HVAC? So I really want to take a very simple approach to this. There's a lot of electronic science in behind Triacs I could get into. I do have a basics electronics background, just in things I've done in the past. But at the end of the day, a Triac is just, its actual name, if you really want to get technical, is a transistor. Okay, so in electronics world, that's, as we see that as a transistor, at least that's the background I have, that's as what we refer to them as, and they're really nothing more than a solid state relay. Okay, so, or that's how they get used. So what we end up doing with them is they have a C, E, and B terminal. That's a collector, an emitter, and a base. And essentially, one terminal is you're basically like your coil voltage coming into it that engages the transistor. The other one is basically like a power coming in, and then the third leg is your power going out. You can have a PNP or a NPN style transistor, or Triac. It's nothing more. It's no more complicated than just it's serving the purpose of a relay. So the old style controllers, they use actual dry contact relays for a very long time. It was very effective. It worked really well for the trade, but they're more expensive, and they require a larger physical profile. So that's one thing that made Triacs really popular, was they're a lot cheaper to install, a lot cheaper to use. They don't require as much circuitry, and they're a lot smaller profile. So you can fit a lot of Triacs into a very tight space where a group of relays wouldn't be able to fit in that same spacing, and especially have the circuitry laid out correctly to where it all wasn't going to cross itself either. So that's where Triacs became a very easy, very cheap, a great solution, but they have a drawback. And my big drawback that I see with Triacs are they do not handle load. So with a dry set of contacts, you know, on the older controllers, it didn't hurt them as much, and you didn't run near as much risk whenever you try to run any kind of load through those contacts, right? And when I talk about a load, I'm not talking about, you know, a motor or something along those lines. I'm talking about, you know, a coil for a contactor or a starter or something along those lines, you know, a motor starter. That's where it became an even bigger necessity to use ISO relays, or isolation relays. So isolation relays allow you to separate the power flowing through the Triac and the signal it is sending out from the equipment power being used, so that in no case can it short and cause a failure internally in the Triac, because it's a lot more sensitive than a standard relay would be. So that's what we have to look at and pay attention to, is, you know, whenever we have a Triac controller, those relays are very, very important to use, and use properly, and to make sure that you are actually isolating that power, that control signal power, so that it's not crossing with the primary load. Because say you have a motor starter and that starter shorts out for any reason and causes a surge, the dry contacts on the ISO relay aren't going to be hurt by that. They're barely even going to notice it. If that were to hit that Triac though, that would end up completely frying it. And so what you would do is the Triac feeds the cube relay. So the cube relays are the most common and preferred method to use with Triacs, because they got such a small coil load, and they're very, very well built most of the time. So your Triac is going to fire the coil on the cube relay, and then from there the cube relay contacts will fire and energize whatever load coils or anything else from there that need be, just depending on your application. So again, summarize. All a Triac is just a solid state relay, and it serves the same function as a regular relay. It does it a little differently, and yes, there's a lot of science behind it that you don't have to get into to understand what's happening there. At the end of the day, you are just sending power through a solid state circuit. And so it does not have an actual mechanical armature that's opening and closing. It's doing its flow electronically through the solid state device. And it has a gate in there to accomplish that. And so that's all it is. That's all it is. Okay? That's all you got to focus on whenever you start looking at Triacs. Don't let them confuse you. Don't let them trip you up. Appreciate it, guys. Spend time with the family. I hope this helps. And just as y'all have more requests, keep them coming. Let me know. And I'll try to get the videos out that you guys are needing and you're looking for. Appreciate it.